All right, for this next section here, we're going to continue to use our trig functions that we've been spending some time on. And you guys have been doing some really good work on being able to set up a trig function to solve for the sides, the angles. We just did that ramp activity where we measured the incline of some of the ramps that we have here in the school. And we're going to continue to kind of take those ideas of using trig and applying it to like these real life examples or like story problems. So we're going to kind of spend today where we focus on just being able to figure out how much something is in a picture or in a problem where they're maybe describing a situation to us. So if they don't give us a picture, we're going to maybe want to draw a picture to help us do this. Before we get into it though, and we start talking about too many examples here, we need to talk about the difference between an angle of elevation and an angle of depression, okay? Because there is a difference between those two things, and we want to make sure that we understand when is something describing an angle of elevation versus angle of depression. Now, some of the problems that we've been talking about that we've already done before, even like yesterday with the ramps, you might already have an idea of what I mean when I say angle of elevation and angle of depression, okay? We're going to talk about angle of elevation first. And so the angle of elevation is the angle formed from a horizontal line upward. For example, this picture that I have over here, if someone was standing, so there's this little person here on this island, okay, by that palm tree. If that person was looking up at the airplane that was in the sky, their vantage point from like where their horizontal line of sight would be, so like if they just looked straight out in front of them, like out into the horizon on the like in the ocean, and then you're comparing that to them like looking up into the sky, that difference there is going to create an angle between the horizontal line of sight and the angle of them looking up. That's going to be an angle of elevation. So anytime that we look up at something, that's describing angle of elevation, okay? Now, the same thing could be said then if we're doing an angle of depression. So this is formed from a horizontal downward. Okay, and I'm giving you a couple of different examples here. So in that same situation with the person on the island in the airplane, if somebody was up in the airplane, their horizontal line of sight would be like out into the clouds, okay, out into the sky that they're flying in. And if they look down at someone who is on the island, that would be an angle of depression because they're looking down. Same for the second example, if we have this person sitting at the top of the building and they're looking down at the car, that would be angle of depression. Now, when we look at this one here, this last one, it says error here because the person that drew this picture is mistaking that this angle here would be angle of angle of depression. So I'm just going to put a little note here that this must come from the horizontal. And I'm going to abbreviate that because I don't have a lot of space. But when you're drawing an angle of elevation or an angle of depression, you have to have the horizontal line of sight factored in. You have to have the angle coming from the horizontal line of sight. This one is not, because this person's horizontal line of sight would be going out like this, like we saw in that other picture, and it would be this angle instead. The horizontal line of sight is not matching up with where they put that one. And so we don't want you to think about that when you're thinking about angle of depression, okay? Think about yesterday when we did our ramps activity, okay? If I had that ramp problem like we talked about yesterday, so I'm just going to draw an illustration because we kind of talked about that in class. When you guys had to measure the angle of incline of the ramp was underneath the ground, right? We weren't able to like drill into the ground to figure out, okay, where's the horizontal and like, where's my angle, right? How did we, if this was my ramp and this was the angle I was looking for, how did we think about this picture in order to actually do those problems yesterday? What were we doing? Yeah, remember we were taking that triangle, we were like flipping it upside down. So this picture is the same thing. If I flip this triangle upside down and I switch my vantage point like this, if I were to like sandwich those or like overlay them a little bit and put them on top of each other, they would make a rectangle. And so remember when we talked about rectangles a couple of units back? When we had a diagonal drawn in, it created two similar triangles to each other, two congruent triangles, and they were just the inverse of one another. So that same thing is happening here. Okay, so if you are working with a problem and it's maybe hard to look at it as an angle of elevation, maybe flip it upside down, and maybe the angle of depression kind of situation is easier depending on maybe what they're providing you with context-wise for the problem. Okay, so it's just important to know that when you have a problem, so even like coming back up here, this person on the island looking at the plane, like these two situations, the angle of elevation and the angle of depression here, like if the person in the plane were like stopped mid like time, like time froze for just like a couple seconds, okay? We were able to take measurements from the person looking up at the plane and the person looking down at the plane. If you just could like freeze time and look at those things, those two angles should be the same amount because they're the same triangle. It's just one's like inverted upside down, okay? What I want you guys to do here really quick is down below, they're giving you a couple of examples. I just want you to write out if this is angle of elevation or angle of depression that they're showing you. And you can use E for elevation and D for depression if you don't want to write out those words, okay? So take a quick second, look at these 5 pictures down here and just write elevation or depression. Okay, I'm just going to quickly zip through these here. This first one should have been elevation. This one is depression. Next one is elevation. Next one is elevation again. And the last one should have been angle of depression. Okay, we good on that? All right, if you guys flip your page over, we have a couple of problems here. Trig word problems we're going to read through. If you can, draw yourself a picture. You don't have to be an artist here. Okay, so they're going to be describing something happening. If you want to add some detail to your picture and actually try to draw whatever they're talking about, that's fine. I'm not an artist. I can barely draw stick people. Okay, I mean, I can draw a triangle and that's about it. So I'm going to make sure that I'm going to draw something that maybe makes sense to me, but I'm not going to be super elaborate with my pictures here. Okay, but you could add as much detail to these as you want. Remember, we are still thinking about SOHCAHTOA here, because eventually we're going to have to use one of these functions to help us solve for whatever is missing, okay? But because there's no picture provided for you, you might want one to help you kind of see what's happening here, okay? So let's take a look at this first one. It says a 3.4-foot guy wire is attached to a tree 3 feet from the ground. What is the angle that is formed between the wire and the ground to the nearest degree? So when they want an answer here, we want a nice, clean, rounded number. So we don't want any decimal. We're just going to have to round it up or round down to the nearest whole number. Okay? So I'm going to draw a right triangle here. If you need to, you can kind of think like, okay, there's a guy wire that's attached to a tree. So I'm just going to maybe draw. Here's my tree, okay? So this wire is attached to the tree here from somewhere in the ground. Now they're saying that the wire is 3.4 feet. So from the ground up to the tree. Now it's going to be attached to somewhere in the tree up here. So I'm talking about the length of the hypotenuse is going to be my 3.4. So that takes care of this number. Then it goes on and it says it's attached to a tree 3 feet from the ground. That means that this tree is only 3 feet tall. It's kind of a short little tree. Okay, so the height of the tree would be that tall side of my right triangle. So that's going to be going here. So that takes care of that number. They want to know what is the angle that is formed between the wire and the ground. Well, the ground would be this flat base side of the triangle. So I'm trying to figure out how much this angle is. Okay, this would be an angle of elevation problem because I'm looking up from the ground to the tree. Okay, that angle is formed between the horizontal and that angle of incline there. So I want to figure out what sides I have. So if you look at theta, you use that as kind of like your baseline. What sides do you have? Opposite, hypotenuse, adjacent, what do you have? 3 would be opposite and 3.4 would be hypotenuse. Good. So what function is that? Good, that's sine. So we're going to do sine of theta is equal to 3 over 3.4. Now remember what we talked about 2 days ago. How do we find the measurement of an angle? You have to use the inverse, okay? So to find theta, I need you guys on your calculator to hit your second button first, and then hit sine, and then do 3 divided by 3.4. And what are you going to get? We want this rounded to a whole number. Yep, I got 61.9. So would I round it to 62 or keep it at 61 degrees? Good, you'd have to round it up to 62 degrees for your angle there. Okay, so it's really no different than what you guys were doing before. I'm not changing anything about how you set it up or how you solve it. It's just you're going to have to read through the problem, get the context so that you can figure out what's maybe missing, okay, and what you're needing to find. All right, I'm going to skip over 2. Let's go down here to number 3. Let's do 3 together, and then I'm going to give you guys some time to do 3 and 4 on your own. All right, so 3 says a little boy flies his kite. The string forms an angle of elevation of 37 degrees from where he stands to directly under the kite is 45 feet. How long is the kite string to the nearest foot? Again, let's draw a right triangle here because we know we're going to be putting this on a right triangle. All right, now we have this person who's doing a kite, so I'm just going to draw this little boy over here, and then his kite is up here in the sky. Okay? So I've got my kite up in the sky here. Let's read through the problem again and let's label our sides. So a little boy flies his kite. I'm just going to cross off stuff as we go. Nothing in that was very useful to me. The string forms an angle of elevation of 37 degrees. Okay, angle of elevation. So where in my picture should I put the 37 degrees? Should be down here by the boy, right? Because it'd be like from his horizontal line of sight and then looking up at his kite in the sky. So this angle down here is where that 37 goes. Okay, so now I'm going to keep crossing all that off. Okay, and from where he stands to directly under the kite is 45 feet. Okay, so where he's standing and then right underneath where the kite, so directly underneath the kite would be like here, they're saying that the distance between him and that spot is 45 feet. Okay, so 45 feet needs to be on the bottom flat side of your triangle. Remember, this is where the 90-degree angle would be. All right, that takes care of all that. Then it says, how long is the kite string? What side of the triangle would the string be on? Yeah, it'd be the hypotenuse, right? It'd be this side. Okay, so I'm going to go ahead and think about what sides I have now, all based off of the 37 degrees. So the 45 would be my what side? Good, adjacent, and the x would be, good, hypotenuse. So what function is this? Cosine. So we would do cosine of 37 is equal to 45 over x. Good. Now, we've seen problems like this before. How do we solve for the x? Okay, and then what do you have to do? Okay, you have to divide both sides by the cosine of 37. So now we're going to need to use our calculator, and you need to take 45 divided by the cosine of 37. Okay, and again, they want it to the nearest foot, so you're going to have to round to a whole number. So go ahead and type that in and tell me what you get. Good. 56. I have 56.3, so it's good to round it to 56, and that would be feet. That's how long his string would be. Okay. I'm going to give you guys a couple minutes here to do both 2 and 4. All right. So I'm going to give you some time. Go ahead and work through those, and then I will do a real quick run through of the answers when I feel like everyone's got it done. Okay. So go ahead and get to work. Okay, so while you guys were working there, I went ahead and drew a couple pictures to kind of illustrate what was going on these two problems. So let's start up here on number 2. How would I set this up? What function am I using? tangent, because you have opposite and you have adjacent. Good, so it'd be tangent of 55 equals x over 21, and then you would multiply by the 21 on both sides. And so what would I get? And again, we're rounding to the nearest meter, so I want a whole number here. Good, 30 meters. Very good. Okay. Now we got the last one here, number 4, talking about this airplane. What function are we using here? Tangent again. Okay, so tangent of the 15. What's your opposite side? Good, 3,000, and the adjacent would be x. Okay, so now this is that one where we've seen this show up a couple times. You have to multiply by the x, right? And then you have to divide by the tangent of 15. Some of you might start to get to the point where you can see anytime it's set up like this, you're going to take that top number divided by whatever your trig function is. So it should end up looking like that. For this one, you needed to round it to the nearest 100 feet. So if you take 3,000 divided by the tangent of 15, you get 11,196, but we want it to the nearest 100 feet. So what would you round that to? Good, it'd be 11,200 feet. Very good. All right, any questions on those word problems?